the minimum residual oil out of extractor, it is convenient. It's the more convenient option, and is for the session processing ABCs. Thank you for inviting me for this presentation in this AOCS annual meeting. Well, I'm sharing with you now the presentation. What you see in this picture, it is the largest plant, the largest crushing plant in the world, with 33,000 tons per day soya, that is located in the area of Rosario, Argentina, in front of the Paraná River. Well, but our agenda, it will be trying to give answers to these two questions, very important for operation in a crushing plant: how to get the minimum residual oil content, and if by getting the minimum residual oil content is the correct, is what we have to do. Okay, how to get the minimum residual oil content. And this is, we can follow these 5 parameters to have a good approach on how to do it. Started with the contact time. We know that the extraction process can be taking place from all the side of each particle in the material bed. And the contact time is the time spent by the particle, by the flakes or expanded, soaked by micella. It's not just residence time of the material into the equipment, but the contact time. It is then very important to flood the material in a bath of solvent at each stage to maximize the contact time. And we can see these like sketches like to make more clear that when it is a zone of percolation, the contact is not very good, as the micella has contact with just partial parts of the material. But once we get immersion, we have completely any particle in the middle of the bath. It is completely surrounded by micella, and then we have a perfect contact. And the operation, the ideal operation, it is when it's completely flooded. Naturally, should to be some percolation. Otherwise, it would be stay with the same micella all the time. But we need percolation, but at the same time, contact of the micella with the material. And which can be seen here, it is clearly, this is a real extractor in a plant of 12,000 tons per day. It's completely flooded. It's, I guess it's clear that is all this is flooded with the micella, but the material is just underneath of short bath of micella. And something that you can maybe see is this bath, in this case with canola, with grape. The other one is soya, where it's possible to see the material completely flooded by the micella. As well, it is possible to be shown here that in some cases, in particular reasons, it is convenient to have flooded, but dry in the middle, like it is in the last part of the extractor when it's solvent. It's good to drain all the micella as possible, but to have flooded with solvent later on. Okay, the other parameter we mentioned in the beginning is the flake thickness. Naturally, the thinner the flakes, the better the contact and the less residence time we need. But the problem is that we need much more energy in the preparation, not only energy, but also maintenance to have a perfect flakers. And then it is very costly operational and maintenance cost to keep such thinner flakers. So the best compromise we found it is to have a flake thickness of 0.38 millimeters. Something like in between 0.38 to 0.40, 0.42 some cases, but the largest plant in the world use this kind of flake thickness. About the temperature is very important also. You know that depending on the commercial hexane quality, but it's about 63 the range boiling. The boiling range is in between 63 to 69, so it is convenient to work about 60-62 degrees C in terms of keep safe the plant without pressurize and at the same time have a good extraction efficiency. Other point which we would like to know to talk about is that higher percolation rate is the better the oil destruction, as the increase of the renovation of the micella in contact with a specific part of the material being extracted. Although a high percolation rate is desirable, not always the material coming from the preparation plant has a good, but most important, reasonable constant percolation rate. Indeed, if we, depending on the seed, on the preparation difference, if we have expandate, good quality of expandate. In example, we have about 49 cubic meters per hour per square meter, but if we use flakes with 0.38 millimeter thickness, we will have something like 20 cubic meters per hour per square meter, like percolation or flux rate parameter. But if we use 0.3 millimeters, we will have almost half of that. Naturally, this will continuously changing depending on the fines, moisture, quality of material, etc. So we have certain devices to catch the angle of this arrow. It will relate the micellar percolation rate through the material. The steeper the arrow, the higher the percolation rate. And then the orientation should to be in such a way that we catch the same micella at the same point. But if we change the percolation rate because of the material quality, so we are able in our extractor, in the reflex extractor, externally we can change the position of the micella hoppers in such a way that changing bulbs positions, we can catch the same flow, avoiding any contamination with weakest micella, which would increase the final oil content. Something like that is always also happening with the solvent retention, which is not a pure solvent, but micella at the rate of 0.5, 0.3% of oil that will be carried to the DT. So in such a way, the minimum the retention, the minimum the oil carry out also to the DT. So we have a design for a special extractors that we have a patent system where it's possible to reduce about 1 to 2% of the solvent rotation, depending on the present hexane hold-up figures. The patent system, we call it quick trip, and it is about hexane vapor recirculation in such a way that make the latest part of the hexane hold-up in the material itself will be dripped out from the material with the result of a minimum hexane or micellar, very diluted, but micellar amount out of the extractor. So this is a plug-in system that can be used in a extractor of the fixed bed, like the reflex one. Well, but coming finally to the question is to get the minimum residual oil content is correct, and I would like to make another question similar, but is always convenient or only for the plants where there is only crushing without refinery? Because many people think that only is convenient when it is only crushing plants, but not with refinery. And here are the concepts involved in this that we have to know involved in this question, and it's that when we are extracting oil, also we are extracting some other substance. Basically, is oil with different content of phospholipids and free fatty acid. So we can see that when we extract up to, I will show later all the different amount of phosphorus and free fatty acids content at different stage of the extraction. So when we extract up to 0.5%, the phosphorus is, in this case, flakes, 550 ppm, but free fatty acid is 0.8. Okay, it's a special, well, special no, it's the amount of free fatty acid existing in this seed. But and it can be seen here, but also free fatty acid and ppm of phosphorus. But when we go further in extraction, and we get 0.3, a limit, by the way, in a realistic real extractor, we will get much more phosphorus, 3,500, but also much more free fatty acid up to a level of 6.32%. But by simple mass balance, we can see the amount of oil extracted at one level or to the other, and we will see that when we mix up everything, we will get very similar composition of the total oil than we have at 0.5. Instead of 550, we have 575 ppm of phosphorus, and instead of 0.8, 0.84% of free fatty acid. Correct? So this is the different level of phosphorus content by extracting up to 1.8 residual oil content, by to 1, to 0.5, to 0.3. These are the figures we use. But we get all these figures up to naturally with the oil, with the amount of oil extracted at this at every of these residual content. We have at 550 and 575 when we go up to 0.3. You can see that here it's something like 7 times the the amount of phosphorus, and about 10 times the amount, or 9 times when we go in free fatty acids. But similar situation is when we go in expandate. When the same work it was done with expandate, where we have all these different levels of phosphorus and free fatty acid. It's much less the difference when we use phosphorus, but when the difference in between a bad extraction and a very good extraction. But I use the flakes, which is the more expanded, or the more split over the world, the flakes. So by using the figure of flakes, we have this crude oil in a extraction plant. The yield of crude oil 557 and 562 metric ton per day, with a difference in favor naturally of the 0.3 residual oil content of almost 5 tons per day in the solvent extraction plant. But if we do the mass balance in refinery, considering with neutral oil losses with this formula, I check it out with different formulas. You know, it's not always the same, but I check it out with this. This is the formula that apply the company which were behind of all these tests, but also the loss over neutral oil losses, which is 25% on top plus 0.3, and we use a different with a different amount of phosphorus and free fatty acid. We have that the difference in is reduced naturally because the amount of phosphorus and the phosphatides and the free fatty acids is bigger. But at the end, always it is much still of the oil after refinery. It is not 5 but 4 tons per day in favor. So when we do the conclusion that 4 tons per day in benefit of the lower residual oil content, we have for a plant that the figure it was done for a plant of 3,000 tons per day plant. The extra yield is about $400 per year, considering extraction and refinery as a benefit. I use the price of crude oil for doing this number. So it is naturally it is clearly a benefit. So trying to answer the question if it's convenient or not to use the lower the residual oil content in any plant. In any plant setup, is convenient to have the minimum residual oil content, no matter if it is only extraction plant or extraction plant plus refinery. And even that difference of the extra yield can be improved by using enzymatic degamming, or the other option is to improve the result to use GAM enzymatic deoiling, which is a Desmet patented process that also it's available in some other presentation in some other session. It's an alternative process for GAMs. So this is all I have for this case. Thank you very much for your attention. There you have my mail in case you want to make any questions or comments, and it would be a pleasure to answer all of you. Thank you very much for your time.